Geotrig, lesson 21. This is day 2. Today we're going to talk about domain, range, how to tell if it's a function by looking at its graph, how to tell if it's a one-to-one function, finding out how to state domain, how to state range using interval and inequality notation, and set notation, stuff like that. So enough information, but it's going to hopefully go pretty quick. Guys, your domain. What is the domain? We talked about this yesterday or no?
No. Oh, no.
We did or no? We did? I thought we did. So, domain, guys, are the x values.
X is in Texas.
Okay? And they're your inputs. And they're the independent. We did independent and dependent yesterday, right? So this is the ones that you control. The range, yes we did because I remember talking about this now. The range is like going to the driving range or the batting cage, right? We talked about this. Otherwise, the outputs and the dependent values. Now it says you can't use numbers as replacements for x that indicate dividing by 0 or that we require to take a square roots of negative numbers. Hopefully those rules are already ingrained in your mind. You can't divide by 0 in your free time. Ask Siri because you don't have friends. You can't divide all your stuff by nothing. Something like that. Yeah, she goes into a long-winded explanation of why. So listen to her if you're not going to listen to me. Can't divide by 0. So basically, it's values that make it true, and you either state the values that make it true, or you state the values that make it true, and then put the exceptions of, but you can't be 3 because you can't divide by 0 because 3 would make it 0. That type of thing. Or if it's going to end up having a square root of a negative number, obviously square root of -2 is not real. Okay? You guys should know how to handle it because we got imaginary numbers, but it's still not real. Okay? Any questions on any of that? That should be kind of a review from what we did yesterday, a little bit of review of that Algebra 2 type stuff. So, there are types of notation. So when I ask you for the domain of something, I want it stated very specific ways. 2 different ways. And I think at this point, because of teaching pre-calc several years now, stuff like that, I want you to actually write both. I want to see set notation and what we call interval notation. So, this, well, you guys would hopefully agree that this is an inequality. X is greater than 3. I would also hope that you would be able to graph that. I have a critical point at 3. What kind of dot is this? Open or closed? It's an open circle. And I have to shade to the left or to the right. Which side do I shade? To the right, because I'm looking for values bigger than 3. Or if you did not know this, I can check a point like 0. Is 0 greater than 3? No. Here's the thing. This is shading. If I'm not on the left side, then it means I must be on the right side. If it's not heads, it's tails. So therefore, it's here or it's there. And if it's not on the left, then it has to be on the right. So I would shade this way. So you got a graph. You have the inequality. How do we state that using what we call set notation? Therefore, we're going to use curly brackets. It's the brackets that look like that. So they are a little bit tricky to draw. They look something like this. And the way we like to set it up is almost 99% of the time for us, we're talking about real numbers. We want only numbers that are real. And so they say x on the real numbers, that little backwards E thing means within, contained in R. Big R means real numbers. Such that, and now guys, I'm rewriting exactly what it states above, but its x is within all the real numbers, such that, that's what the line is for, such that x is greater than 3. End your bracket. X is in real numbers, so x of all the real numbers, so you get to choose anything you want for real numbers, but it only exists where x is greater than 3. The reason why we state this first part of x is greater, or x is within R, or x is contained in the real numbers, is because maybe your problem up here, or the one we have here, has other variables in it. So if it's in S, then you say S is in the real numbers, such that S is greater than 3. Okay? So it does not have to always be X's and Y's. You kind of get that idea. Now watch this. I'm going to change this up a little bit. Or should we say, I'll give a different example. I'll change colors so you can see it. What happens if I went and did something like this? A close dot, open dot. Let's make this at 2, make that at 7, and I am shading to the center of those. What would that be in set notation? Let's use the variable x, okay? I'm going to pause it so we can give you some time. So, I'll put it over here. Starting with the squiggly bracket, right? X is within the real numbers, such that, how would I write this one? Bless you. How would you write this one? 2 is less than or equal to x, which is less than 7. That's a really bad bracket, but end the bracket. That's it. I'm just writing it basically with inequalities. I just add this extra stuff in front so I'm stating the domain correctly. Okay? It's where the x's exist. Any questions on that? That is set notation. Interval notation, the second group here, it uses parentheses and brackets. So we're going to use parentheses, which you guys would know as parentheses, and the brackets that are straight, not the squiggly bracket, but the straight bracket. Okay? Now, what you guys need to know is that I'll pick a color here so we can see. Kind of a greenish color. This bracket right here on the left, which is it's more of the straight bracket, not the parentheses. This denotes included. It's included. A parentheses is not included. And how do you know if it's included or not included at the ends? Is it open or is it closed? So if I wanted to go back and restate the domain and range for the red stuff and the purple stuff, I'll go back to red. These ones may be a little bit easier. D, domain. It says 3 and up, right? X is greater than 3. So you have to go in the same order, guys, as we have here. So one of our endpoints is 3. 3. Comma. Is 3 included in that group? Is it included? No. So guess what? It gets a parentheses. Where is it going to? Infinity. That's your other side. I got a question, guys. Point to something and say that's infinite. Show me what infinite is. The sky's not infinite, right? There's nothing you can point to that's infinite. Time's, I don't know, it's time infinite? You can't point to time. You can point to a clock. It'll stop. Right? Infinite goes on forever. Can you ever be at forever? No. So that means infinity is never included. It's a open parentheses or a parentheses. You guys see that? You can never be at infinity because as soon as you're there, someone will go one part past you, and now they're there. And then you're like, well, no, I'm going to go a little bit further. And then you're going to go a little bit further and a little bit further and a little bit further. The whole principle of infinity is it never ends, right? So you'll never be there. Going to the purple one. So if I talk about the domain here, what are my endpoints? 2 and 7. I'm all the numbers in between, but can I be at 2? Yes, so I put a close bracket. 7? No. Open. Done. See how much easier it is to use interval? And remember, now, when we talk about interval, we're talking about the range here. Values go between 3 to infinity. 2 to 7, including 2, not 7 though. Okay? That's how we use set or interval notation. So, I want both the set and interval notation for these 3 graphs. So basically, guys, we're going to start off every single one of these domains as it's all real numbers. Such that, or only from, only certain places. And I chose these graphs because each one of these graphs have some type of limitation. The first one's a square root graph. What can't we do in square roots? You guys all should know this. We talked about this already today. We did. You can't take a square root. Negative numbers. So the question about this is, if I can't take a square root of a negative number, that means this number or this thing inside of 10 minus x needs to be positive or can't be negative. The 10 minus x itself can't be negative. It can be 0, right? Can you take the square root of 0? Square root of 0 is 0. So therefore, guys, the domain is where 10 minus x is greater than or equal to 0. Can you solve that for x?
Yes.
What's the easiest way to do that?
Subtract 10.
I'm not going to subtract 10.
Oh,
I'm going to add x.
Yeah.
So I get 10 is greater than or equal to x. Now, we should be able to, in our minds, say that a different way. 10 is greater than or equal to x, which means the same thing as
X is less than or equal to 10.
x is less than or equal to 10. Right. I think most of us would be more comfortable with the one on the right here, right?
Yeah.
When I say 10 is greater than x, greater than or equal to x, we might be a little, okay, what numbers can I put in again? But if we say x is less than or equal to 10, almost everybody instinctively say, oh, that's 9, that's 7, that's a 5, that's a negative 4, negative 5. Whoa, 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 whoa. Negative 4, negative 5? Those work?
Yeah.
Why?
Because they're less than 10.
because they're less than 10. It should work.
Infinite.
Here's the problem. Or, well, here's the thing. Put in negative 4.
For X.
Or put in negative 6 to make it easier for you.
For six.
What's the answer? If I put in negative 6, what does this problem equal? You evaluate for f of negative 6. Okay?
Oh.
Yesterday. F of negative 6, what does it equal? It is 4. It is 4. Because you subtract a negative, you are adding. So you get 16. Square root of 16 is 4. That's why it's working, guys. That's why it's really important for you guys to set whatever's inside bigger than or equal to 0 and solve it so that you know exactly what values you can put in. Okay, we need to state this. The domain is of x on real numbers such that what? You already did the work.
Oh, X is less than or equal to 10.
10. Done. That's one of them. Which one is that?
That's the set notation.
Set notation. Now we'll do interval notation. Interval notation. Oops, sorry. What are their numbers going in?
10 and infinite, right?
Mm.
Oh no.
So which side is the x on and which way are the numbers going?
Wouldn't it be anything less than 10?
Anything less than 10, that's what we said.
Yeah.
So it's 10 is one of our numbers. What's the other number? It's not infinite,
It's not infinite.
it's negative infinity. Where's negative infinity in reference to 10?
In front of it?
In front, better, what side?
Oh, the left.
Left side. So then, therefore, we're going to put negative infinity over on the left, 10 on the right. You can never be at infinity, so that's an easy one. But can you be at 10? Done. I want you guys to think about g of x. Try it on your own. Okay. What's the answer to this, guys? I'll help you out.
It would be X.
Such that?
X is greater than or equal to, sorry, 2?
No.
No. That's not right.
What's the limitation? Is there a limitation on this one? It's a fraction, guys. Is there a value of x that would not work? What can't you divide by? We talked about this already today. 0. What would make that 0 on the bottom? 2. So can you be at 2?
No.
No. Is there any other seemingly obvious number that can't be? Can it be a 4? Can you put a 4 in for x? 4 minus 2 is 2. 1 divided by 2 is a half. Hey, that works. Any other number works except 2. So x is all real numbers where x can't be 2. Done. So now I just have to state what it can't be. Now things are going to get a little sneaky and tricky here. Because if I was to graph this, what would it look like on a number line? Here's 2. You're saying it can't be 2, right? It's open.
But it can go both.
Yeah, it goes, yes, it can be shaded both ways here.
It can be anything besides.
It can be anything except that 2. How the heck do I go about stating that in interval notation? Almost. Can't go from one side all the way to the other. You got to make a leap, Tommy. Is your hand up? Oh, it looks like it.
Wouldn't it have to
With
be
your pencil.
negative?
Okay. What? Okay. Let's put what was said from negative infinity to infinity. But unfortunately, you're not everything in between.
Fair enough.
And you're not allowed to say can't be equal to 2. You have to state that leap. You're running, and you jump over. And you continue on. How can I state that with intervals? What if I made 2 intervals? Can I make separate intervals for each side?
Oh, yeah.
So I can come from negative infinity to 2. Am I included on either end? Nope. Then I can go from 2 to infinity. Am I included on either end?
No.
Nope. Now the only thing is that I need to somehow link them together. It's the U thing. Something we need to learn now.
What is that two? Oh, no.
The U in the middle, okay? When we're talking about a U, it means union or intersection, not intersection, sorry, whoa, don't say intersection. Union is the marrying of those 2 intervals. Kind of putting them together for all togetherness. I don't know how you say it. Okay?
Trinity?
No, just you're putting all of the numbers or elements together. But you notice that you still, in each one of these, if you put them together, you don't get 2. Because 2 is not included in either one. You kind of see that? And then we have another symbol. It's an upside down U. If you see that between 2 intervals, this is the intersection. And what I mean by intersection means only the ones they have in common. So if they both have a 1, then the answer can be a 1. If one has a 2 and the other one doesn't, then 2 doesn't go along. Okay? So we got unions, we got intersections. For us right now, we're only going to use the union, the U, between 2 sets, kind of marrying them together. The third example is going to have to deal with some of this stuff of putting things together. There's a couple things. We've got a square root, and we're going to have some things we can't be. Sometimes they overlap, sometimes they don't. I'll give you guys a couple seconds to try to figure this one out on your own. Some things about set notation, guys, is that you can list several different things. So you can say that things are greater than 5, but can't be equal to 7. That's okay. In intervals, you can have more than 1, more than 2, more than 3 intervals as long as you use the union, right, to kind of marry them all together. This square root is just square root of x. That's pretty easy. What does x have to be?
Anything other, either,
There's a better way than saying anything but not negative. Okay?
yeah.
So what is? How can we say that? Say it again.
Anything.
Not you, Spade.
Oh.
Esme. Say it again. You were saying something.
I said 1.
Said 1? 1 will work. I need more than just one number, though. I want all numbers. Just the square root of x. What are the values that will work? Any of them that are positive and 0. So how do you say that? How do you say that, guys?
0 to positive.
0 to positive. Yes. How do I state that with inequalities?
0 to positive.
Thank you. X on the real number such that x is greater than or equal to 0. Yes?
Which is greater than?
which is greater than 0, greater than or equal to 0. But here's the problem. There's still a problem with the denominator, because it can be 0 at 2, which then it'll give me a problem. Comma. X can't equal 2. Yes. That's what I tried telling you. You can piece things together with inequalities. We're stating, overall, it's got to be greater than or equal to 0, but it can't be 0. It's kind of like when you guys say, well, my room's always clean, except for last Saturday it wasn't. Or something on those lines. You guys know what I'm talking about. Right. So that's what I'm saying. You guys use this all the time. Oh, I always do that. But, except for that one time or that time before that and one time before that. Okay? Then, if I wanted to state this using interval notation, 0, comma, what? 2, is 0 included?
Yes.
2 included?
No.
No? Symbol in between?
Bracket U.
U. What's next? Parenthesis. 2, comma, infinity, parenthesis. I'm just linking a couple of them together. Not so bad, is it? Very logical. I'm going to skip over this. The reason it's saying find the domain and range, then graph, is because each one of these, now these are square roots, the inside part has to be greater than or equal to 0, which allows us then to find the values that we would put into a t-chart so that we could graph it. Okay? So it kind of tells us where do we start. So take careful note of where things start so you can make a t-chart in the right places, and then you evaluate those x values to get the y values, plot it. What I want to move on to is types of functions. We have types of functions, and the types of functions can be a relation. Now wait a minute, a relation does not necessarily guarantee a function. A relation, guys, is a mapping correspondence that maps or has every member in the domain to one or more members in the range. Basically saying you have inputs to outputs. Okay? That's different than the relationships you guys have. So, inputs to outputs. That's it. That's all the conditions there. Then we move to the next level and say, is it a function? And a function, guys, remember, assigns a single unique output for every input. Exactly one output for every input. We talked about that earlier today. Okay? Here's a cool thing. All functions are relations because they make inputs go to outputs. But not all relations are functions. Because you can have a relation that has two values, or the same value going in, so like 2, going to a 4 and a 6. That's the relationship. That's a relation. But it's not a function. But because of the definition of a function, you will always have an x value going to exactly one output. So they still have an input to output. And then we could take it a step further than a function, and we can call it a one-to-one function. A one-to-one function says that every element in the range, the y's, of the function, so it has to be a function first, corresponds to exactly one element in the domain. Now before we talked about a function as in sometimes if you go to a soda machine, right? A high volume soda machine, they will allow more than one button going to the same soda. You guys have all seen that, right? There may be 3 Mountain Dew buttons. You hit a Mountain Dew, you'll get a Mountain Dew. If you hit a Mountain Dew and get a Mellow Yellow, you're kind of irate, are you not? Okay? Because we all know they're not the same soda. Then it's not a function. It's not functioning correctly. A one-to-one function or a one-to-one machine would have exactly one Coke button, one Pepsi button, one of every button, because you're not allowed to have more than one different output going to the same, or input going to the same output. So it takes it one step further. There's a one-to-one match. Okay? Homework is page 158, 1 through 2, 9, 14, and 28. Have a great day.